on this worksheet? What can I help you with? We're not just on the front or the back of the first page. Number 9, the x squared over the x squared plus 2x minus 3. Is that the one? Okay, I thought I said something like that, but who knows? All right, so we have this problem. Okay, so first thing I would do is this. This looks like a pretty complex problem, but the only thing I want to be able to answer right now when I look at it is because we're talking about less than 0, we're talking about negative. Negative would mean where is it below or touching, because they're equal, the x-axis. Okay? So we want to know that. Does everyone feel comfortable with that information so far? So then what I would do with that is I would go over and bust out Desmos. Let's see, blank page, Desmos. Graphic calculator. So I'm going to get y equals, I'm going to put x minus 4 in parentheses because I want to put it over something. And then on bottom, I can put this in parentheses as well. Okay, so we want to know that you're seeing all the action of your graph. Okay, yeah, I could zoom out a whole bunch, but there's only so much that's going to take place in between negative 20 and positive 20 in this case. All right, so is this below the x-axis? Yeah, because the x-axis is right here. Agree? Okay. This is all above the x-axis until we get somewhere in this region, and then it drops below. And then this all appears to be above the x-axis. So let's figure out where this point is. So I'm going to kind of jot that down. I know that at 4, it's below the x-axis, okay, or on it. But then this whole thing going down, so we have to kind of figure out what this is. So we're going to count. We're going to say negative 6, negative 7. So at negative 7, that appears to be an asymptote. Okay? And yes, I do have other asymptotes as well. This at 5 appears to be an asymptote as well. So it appears on our graph we have 2 vertical asymptotes. Theoretically, we have a third asymptote, which is probably the x-axis. One thing I'm curious about, and the only reason I'm curious is this bold line seems like it's right on the axis. So I'm just curious if it's going to go ever above it. So I'm going to zoom out just a little bit more to see if it ever appears to go above the axis. And when you can't tell it right away, then you can always just plot y equals 0. And it doesn't appear that the red seems to be going over that blue line at all. Okay, if you're out to negative 10,000, you're totally within that. So I don't really need that. So right now I know that I'm going to have at x equals negative 7 an asymptote, and I also have an asymptote at x equals 5. Remember, x equals a number is vertical line. So those are my 2 asymptotes that are taking place. And then we also said we found this point right here. Okay? So I think with that information, we can answer the problem. So it's below negative, it's below the x-axis from negative infinity up until we get to negative 7. So let's go here. So from negative infinity to negative 7, Go back and take a look at the graph. It's going to approach it. It approaches that 7, but it's never going to get there. So that's going to be a round bracket. And then I'm going to go back and take a look at my graph one more time. And then I realize, because we have the equal sign on our thing, from -4 to 5. So it's a square bracket on the 4 because it's equal there. And then it's going to approach the 5. So square bracket 4, round bracket 5. This is where my graph will exist in the world of negative. In the world of below, on or below the x-axis. Seem okay? So did you see how I used Desmos to go through it? I didn't go through algebraically. I'm taking a look at the graph. I'm utilizing the graph, utilizing the technology. And I want you to realize that Desmos technology, you know, some of you will be off maybe perhaps to college next year or some sort of other education. When you come across stuff like this, start realizing, dude, Desmos is really helpful. It does a lot of really great stuff for you. So is there anything else on up through problem number 14? What else do we need? Solve each inequality. That was number 9. Number 9 says, hey, I got the answer right. Sweet. I love when I get the answer right. I didn't write this book. Yeah. 12. Excellent. Number 12. So we want to use the intersection to solve that equation. So this is one of those where I'm going to still use Desmos. I'm going to use Desmos, and I'm going to have one side be y equals ln x, and the other side is y equals negative x minus 5 quantity squared plus 4. Definitely Desmos problem. Set each side as a y equals. So I have y equals, and I'm not sure where the natural log is, so I'm going to see if they have it here. I don't see natural log here. I'm going to hit functions, see if it's here. Might be under stats. I don't see it there. Miscellaneous. Miscellaneous could be good. Oh, there's my ln. See how I found that? If you can't find it, like on test day, let me know. So I'm not testing if you know how to use Desmos. I'm testing to answer the question, okay? So I have natural log of x. Oops. Okay, natural log of x kind of looks like that. Natural log of x basically has 0. The y-axis is an asymptote. And then I'm going to graph my other one. I'm going to get y equals negative x minus 5 raised to the second power plus 4. Okay? So we want to do the intersection. So I'm going to go here and here. I'm only going to look at the x values. I'm not worried about the y value. But at each of those x values at 3.327 is one solution, and at 6.461 is the other solution. So those are probably irrational answers, meaning like those are close, but it's a decimal that goes forever. Okay, and that's not really vital to know that. It's just kind of, it is what it is. It's not, it doesn't have to be those exact values. But Desmos is going to probably take things out 3 or 4 decimals and then call it good. Does that make sense how to do that problem? Cool. What else do you see, my friends? Yes, ma'am. 14? Okay. What? I heard you said what? Okay. So I think I will go ahead and use Desmos on this one as well. And I'm going to show you why. We're going to change, my t's are going to become x's. I'm going to change h at t to be y equals. H at t is just functional notation. All right, so I got y equals negative 16x squared plus 480x plus 22. Okay, so look at this. So let's see. Hang on. It says we have that equation, which I agree I have it in there correctly. Okay, use the evaluate tool to find the height of the missile after 1 second, 10 seconds, 25 seconds, and when does it hit the ground? Okay, so I want to try and get this entire graph in my window. Okay, so yikes. All right. So I know that it ends up there, so now I'm going to kind of go back in. All right, so I'm going to plot this. You said 1 second. So t, our x value, is the seconds. So if I go x equals 1, I create a vertical line, and then I have to kind of go find where this is. And this is going to be, actually, let's do this. I'm going to put a bunch of them up there. I'm going to do x equals 10, and I'm going to do x equals 25. Okay, so let's just kind of see what's going on here. I have a lot of information. So this blue is going to go way up here, and then it's going to come back down over here. Okay, it's a parabola. This is what happened at 1 second, so what I have to do is I want to find the intersection way up there. This one is at 10 seconds, so I want to find what the intersection is way up there. And this black is 25 seconds, so I want to find the intersection way up there. So rather than condensing my graph down to like goofy looking, I'm just going to stroll on up here. And I'm trying to keep my graph in the whole screen the whole time. And I'm not going to give you one where this is like at, like 1,000,006 or something where, 14 days later you finally scrolled up to the right location. Okay, so looking here, I'm going to zoom in on this a little bit, on the green and the blue. So I'm going to look at the green and the blue. So right now, where the green crosses the blue, it appears to be getting closer. Zoom in a little bit more. Zoom in a little more. When I zoom in, it gets wider because I'm like using a microscope basically. We're almost there. If you have any shopping to do right now, go ahead and take care of that. And when you get back, I should be up there. What's up, Dan? Yeah, give me a sec. Have a seat in one of the desks available. Notice over here it's counting by thousandths. Uh-oh, something's about ready to happen. We're at 1, 485.99.991. I hate it when I zoom in and it still is not quite there. There you go. That's not it. There's our point. So at 1 second, we are at 486 feet. Now, I will assure you, if I give you something on the quiz that's like that, it's not going to be that bad. It'll be throw a football up in the air, maybe goes up in the air 30 feet, or a baseball or something. All right. You didn't finish, right? Okay. There it is. Whoop. Oh, you need a calculator? Yeah, probably. Okay, got one here. Yeah, buddy. All right. So let's try and make this one go a little faster. Let's find the 10 now. Yikes. Home, 10. Zoom out. There it is. At 10 seconds, I'm at 3,222 feet. And then 25, my last one. This rocket went high. So just kind of, there it is. 2,022 feet. And then the last one should be easiest to do. When is it going to hit the ground? When does it hit the ground? At, oh wait, I want the blue one, don't I? 30.05 or 30.046 if we want to get all fancy. Now, you'll never ask him about a question again because it's like, okay, he's just kind of scrolling on his computer. I think he was buying stuff off Amazon. All right, but I will assure you the one that I will give you as far as the test goes, I will have it like go up 30 feet, so it'd be like, you know, but that's what we got. Hey, what else do you see on just that sheet that you feel you want to talk about? Feel good about that? All right, so my friends, we have this review. This review, I want to make sure you have time to work on it now. You can ask me questions about it now. But anything that is on this review front and back page, which is like 12 problems, could be subject, and anything I've gone over so far could be subject to the test on Tuesday. First 15 minutes, you get to do it all together. 3 problems, 3 more problems, you're on your own. But you get what you worked on together to use as a guide. Cool? Can I stop recording? Everyone happy? You know what you need to work on? Anyone stuck? All right, I'm going to stop recording now.